Question 5, energetics-based question. Standard entropy of formation. You do need to know and be able to quote accurately definitions, especially in energetics. Standard entropy of formation is the heat energy absorbed when 1 mole of a substance is made from its elements and those elements need to be in their standard states, or natural states. Under standard conditions. Instead of writing under standard conditions, why not play it safe and say 298 Kelvin, 1 atmosphere pressure. Okay, so what we're talking about here is the standard entropy formation of methanol. Methanol CH3OH. Methanol, you need to know, is a liquid in standard conditions, like all the other small alcohols. Which elements did it come from? Well, it came from carbon, and the carbon reacted with oxygen and hydrogen. I'm going to balance the equation here. Carbon's balanced, we only want 1 oxygen, half a mole of O2, and we want 4 hydrogens, that's 2 moles of H2. Standard states, carbon is solid, oxygen and hydrogen are gases. Reaction used in the manufacture of methanol given, and it asks you first of all to find the average bond enthalpy. The average bond enthalpy is the heat energy absorbed when 1 mole of a bond is broken gaseous atoms, that's averaged over a number of different types of the same bond. For example, the carbon-carbon bond exists in many different molecules. The value given in the data booklet is the average. They're all pretty close. The value in the data booklet, paper 10, is the average of the common carbon-carbon bond. So the enthalpy change for this reaction, what we're going to do to figure out enthalpy changes is we're going to take a look at bonds broken in the reactant molecules. 2 carbon-oxygen double bonds, 3 hydrogen-hydrogen double bonds. We look up the values of those in the data booklet, and they are going to be positive values, bonds broken, endothermic. We look at the bonds made in the products, and we have 3 carbon-hydrogen bonds. We have 1 carbon-oxygen bond. We have 1 oxygen-hydrogen bond. In the water molecule, we have 2 oxygen that are made in the reaction process. Energy is going to be given out when they're made. You're going to have the negative values of those given in the data booklet. So you add together for the bonds broken 2 times 743 is 3 times 436. And that's going to give you a total bonds broken of 2794 kilojoules. Okay, 2 of these bonds, 3 of these bonds. Bonds made are going to be 3 times 412. It's 3 of carbon hydrogen bonds. It's going to be 360. That is the carbon oxygen bond, and it's going to be 3 of 3 oxygen hydrogen bonds at 463. So 3 times 412, 3 times 463, and 1 360 is the total of 2985 kilojoules. Sum all those together and you'll get a final value of minus 191 kilojoules. It's not necessarily kilojoules per mole in this example. It could be kilojoules per mole of water made, or methanol made, or carbon dioxide used up, but you don't need to state that.